Hello student, discussed about the application of Avogadro's hypothesis. I discussed at first the calculation of atomicity of oxygen by using Avogadro's hypothesis. Next, I discussed about the second application, that is prove the molecular mass is equal to 2 into vapor density. Next application is to prove molecular mass is equal to 2 into vapor density. The third application is to prove gram molecular weight or mass of any gas or vapor is equal to mass of 22.4 liter of gas or vapor at STP. Already I discussed. Next, I also discussed the application of Avogadro's hypothesis, that is, it is used for the clear distinction between atom and molecules. In this class, I will discuss about the other application, explanation of Gay-Lussac law of gaseous volume. By the help of Avogadro's hypothesis, I can explain the Gay-Lussac law of gaseous volume. What is Gay-Lussac law of gaseous volume? What is the statement of Gay-Lussac of gaseous volume? According to Gay-Lussac law, under similar condition of temperature and pressure, whenever gases react together, then the volume of the reacting gases as well as the gaseous product bear a simple whole number ratio to one another. What is the meaning? At first, I want to explain. Suppose think about two gas. Suppose I have taken two gas, that is your hydrogen and oxygen gas. Hydrogen gas react with oxygen gas, form the water molecules. As per the Gay-Lussac law, what is our target? Suppose hydrogen gas and oxygen gas are present under similar condition of temperature and pressure. In this reaction, hydrogen and oxygen are the reactant and here water is the product. According to Gay-Lussac law, if all the gases are present at the similar condition of temperature and pressure, then what will happen? The gaseous reactants bears a simple whole number ratio. That means the ratio of hydrogen and oxygen must be a whole number ratio. That means it cannot be a fraction. That means here the ratio may be 2 is to 1, maybe 3 is to 1, but it cannot be 2.1 is to 1.2. Here the ratio is a whole number. It cannot be a fraction number. As per the Gay-Lussac law, the ratio of the reactants, gaseous reactants, is a whole number, is a whole number ratio. If the product is also a gas, then the gaseous reactant and the gaseous products also bear a simple whole number ratio. That means here the ratio of hydrogen gas, oxygen gas and water vapor must be a whole number ratio. It may be 2 is to 1 is to 2. It is a whole number. It cannot be a fraction. That means 1.1, 2.1. It cannot be a fraction. It is always a whole number. Again, I simply explain. If x plus y gives z, X is the gas, Y is also gas, Z is also gas. Then, according to Gay-Lussac law, if X, Y, Z are kept in similar condition of temperature and pressure, then the ratio of X and Y is a simple whole number ratio. Also, the ratio of X, Y, and Z also a whole number ratio. It cannot be a fraction. It also cannot be the ratio of reactant and product also cannot be a fraction. Let me explain it clearly. Look at that. We know that hydrogen react with oxygen form water molecule. Experimentally, it is seen that 2 volume of hydrogen need 1 volume of oxygen to form 2 volume of water molecule. Look at that. If you want to find the ratio of the reactant, here if you want to find the ratio of the reactant as per volume, look at that. Here reactant means hydrogen and oxygen. Here 2 volume of hydrogen, so I have taken 2 volume divide by what? The volume of oxygen is your 1 volume. 1 volume. That means here the ratio is your 2 is to 1. So here I have written ratio of the reactant is equal to 2 is to 1. Similarly, here 2 volume of hydrogen, 1 volume of oxygen and 2 volume of water. So the ratio of the reactants and product that is must be, that is your how much? 2 volume divided by 1 volume divided by 2 volume. This is for hydrogen, this is for oxygen, this is for water molecule. That means here the ratio is your what? 2 is to 1 is to 2. Now, our target to support this Gay-Luskas's law. That means our target to verify the ratio of the reactant and the ratio of the reactant and products. Maybe it is a whole number, a simple whole number ratio or not. It can be proved by using the Avogadro's hypothesis. So look at that. As per the experimental condition, it is seen that 2 volume of hydrogen react with 1 volume of oxygen form 2 volume of water molecule. Suppose if I want to apply the Avogadro's hypothesis, then what I will write here? Suppose 1 volume of each gas contain n molecule. As your choice, you can take whether n molecule, m molecule, p molecule, q molecule. As your choice, you can write any term. Let one volume of each gas contain n molecules. If I will apply the Avogadro's hypothesis, here I can write for one volume n molecules. For hydrogen, 2 volume is given, so here I have written 2n molecule because one volume of each gas contain n molecules. Your volume of hydrogen is your 2 volume, so here I can write 2n molecules. Next, for oxygen, the volume is 1 volume. So here I can write only n molecules. Next, here water having 2 volume. So here I can write 2n molecules. If I will apply the Avogadro's hypothesis, here I can write 2n molecule, here n molecule, here 2n molecule. Suppose I will take 1 ml of each gas. Suppose I will take 1 ml of each gas. I will take 1 ml of hydrogen gas, 1 ml of oxygen gas, 1 ml of water molecule. And suppose 1 ml of each gas contain m molecules. Suppose 1 ml of each gas contain m molecules. That means here we can say that the volume of m molecule of hydrogen is 1 ml. Here I also I can also say that the volume of m molecule of oxygen is your 1 ml. Here I can also write the volume of m molecule of water vapor is your also 1 ml. Let I have again taken 1 ml of each gas, and it is seen that 1 ml of each gas carry m molecules. Then here I can write the volume of m molecule of hydrogen is your 1 ml. The volume of oxygen m molecule of oxygen is your 1 ml. The volume of m molecule of water vapor is your 1 ml. We know that 2n molecule 2n molecule, exactly 2n molecule of hydrogen is participate in the reaction. Here n molecule of oxygen is participate in the reaction. 2n molecule of water is formed. I have taken 1 ml and find that m molecules of each gas is present. So here I can write, if the volume of m molecule of hydrogen gas is your 1 ml, then I can find the volume of 2n molecule of hydrogen is your how much, 2n by m ml. That means here if I will take 2n molecule of hydrogen in ml, it is in that 2n by m ml. Similarly, the volume of m molecule of oxygen is your 1 ml. If I will think about the volume of n molecule of oxygen, then I can write here n by m molecule. Here, the volume of m molecules of water is your 1 ml. But I have 2n molecule of water. So here I can write the volume of 2n molecule of water vapor is your 2n by m ml. If I will take 1 ml and if I will take 1 ml of each gas and each gas carry m molecules, then as per the data, here I can say that the volume of 2n molecule of hydrogen is equal to 2n by m molecule m sorry 2n by m ml. The volume of n molecule of oxygen is your now n by m ml. Next, the volume of 2n molecule of water vapor is equal to 2n by m ml. Now find the ratio. Exactly, I have taken 1 ml and I have seen that m molecules. Accordingly, I have again derived the volume of each gas. Now take the ratio of the volume of reactant. Here the reactant is your hydrogen and oxygen. So here I can write the ratio between volume of hydrogen and oxygen is your what? 2n. Here I can write 2n by m divided by n by m. This is for hydrogen. This is for oxygen. Look at that. Here hydrogen. Here is the oxygen. If I'll solve, then it gives a ratio that is a 2:1. Look at that. Here there is no fraction. That means this is called a simple whole number ratio. Similarly, if I want to find the ratio of the reactant product, here the reactant is your hydrogen and oxygen, and the product is your water. For hydrogen, I have taken 2n by m. For oxygen, I have taken n by m. For water, I have taken 2n by m. That means here I can say that 2n divided by m whole divided by n divided by m divided by 2n divided by m. If I will find out the common and remove this, then the ratio is your 2 is to 1 is to 2. Look at that. This is also a simple whole number. Give a simple whole number that is your 2 is to 1. The reactant and product also give a simple whole number ratio that is your 2 is to 1 is to 2. Now, by using the Avogadro's hypothesis, we have seen that the reactants have a simple whole number ratio. The reactant and product both have also a simple whole number ratio. This is the statement. This is the main concept of Gay-Lussac law. So here I have given an example and able to explain the Gay-Lussac law by taking this example, that is your hydrogen react with the oxygen to form water. That means by using the Avogadro's hypothesis, I can able to explain Gay-Lussac law. What is Gay-Lussac law? Again, I will define. Under similar condition of temperature and pressure, when gases react together, the volume of the reacting gases as well as the gaseous product bear a simple whole number ratio to one another. This is the statement of Gay-Lussac law. I have explained by the help of Avogadro's hypothesis. Next, I will explain how the Avogadro's hypothesis is used to find out the molecular formula of a gas. Let me explain. Suppose I have taken a reaction. I have taken ozone. I do not know what is the formula of ozone. Already I know ozone having the formula O3, but here I want to prove that the formula of ozone is your O3. If ozone having the formula O3, look at that. If ozone having the formula O3, that means it have three oxygen atom. If ozone is made by three oxygen atom, then here I can say that the molecular mass of ozone is equal to 3 into atomic mass atomic mass of oxygen, that is 3 into 16. Look at that. How I will explain by using the Avogadro's hypothesis. Experimentally, it is seen that when you will take two volume of ozone, and if you want to subject the ozone to heating, then it gives three volume of oxygen. It is experimentally seen. When two volume of ozone is heated, then three volume of oxygen is formed. Again, apply the same concept. Let one volume of each gas contain n molecules. You can take m molecule, p molecule as your choice. If one volume of each gas contain n molecules, then according to the Avogadro's hypothesis, I can write here 2n molecule, because one volume carry 2n molecule. Here ozone having two volume, that means two volume here means 2n molecules. Similarly, three volume of oxygen is used, one volume n molecules. Here three volume, that means here I can write 3n molecules. That means 2n molecules of ozone react with undergoes heating, gives 3n molecules. Now I want to find what amount of oxygen is needed for one molecule, for the formation of one molecule of ozone. That means 2n molecule needs 2n molecule of ozone produce 3n molecules of oxygen. If I want to find one molecule of ozone, then what amount of oxygen will form? That is your 3 by 2. Here 3 divided by 2 is the molecule of oxygen. That means one molecule of ozone having one molecule of ozone produce 3 by 2 molecule of oxygen. From the above data, here I can write one molecule of O3. Obviously, one molecule of O3 is equal to 3 by 2 into into one molecule of oxygen. That means 3 by 2 into 1 one molecule of oxygen. One molecule of oxygen means two oxygen atom. So here I can write one molecule of ozone is equal to 3 by 2 into 2 atom of oxygen. That here 2 can cancel each other. Then here I can say that 3 oxygen atom. That means one molecule of ozone having 3 oxygen atom. That means one molecule of ozone is made by 3 oxygen atom. So here I can write the molecular formula of ozone is your O3. If I will find the number of atom present in a molecule, then I can clearly write the formula of the molecules. Look at that. Here oxygen carry three oxygen atom. Sorry, here ozone carry three oxygen atom. So the molecular formula is obviously O3. These are all the application of hypothesis. In the previous class, I clearly explained about the few application of Avogadro's hypothesis. First is the calculation of atomicity of oxygen. Second is to prove molecular mass is equal to 2 into vapor density. Third is to prove gram molecular weight or mass is equal to mass of 2.4 liter of gas or vapor at STP. Fourth application it is used to explain a clear distinction between atom and molecule. Now the next application, that is your fifth application, is it helps to explain the Gay-Lussac law of gaseous volume. Next is the application, that is your sixth application, is the to determine the molecular formula of a gas, that is your simply called gas analysis. These are all the application of Avogadro's hypothesis. Basing upon the application, now I will solve some problem. Look at the problem number one. Read the important point. At first, read the problem one to two times. Then collect the data. What are the data are given in the problem? Then make a relationship between the data, and also make a relationship between the target and your data and your available data. So here I want to read the problem. One volume of hydrogen. Look at that. One volume of hydrogen combined with sulfur to produce one volume of a gas. One volume of a hydrogen combined with the sulfur. Clear? So that means here the and the sulfur produce one volume of gas. Okay. If the vapor density of gas A is 17, if the vapor density of the gas is 17, then the volume has been measured under same temperature and pressure. What is its molecular formula? That means what is the molecular formula of A? Look at that. What is the molecular formula of A? Actually, what is the problem here? Here there is a slightly problem in the question. One hydrogen combine with the what? Yes. Here I can write to x. Let the here the hydrogen molecule contain two oxygen atom. Let the formula of hydrogen X. Yes, here I can change the question. One molecule of hydrogen combine with the one volume of sulfur, one volume of one volume of sulfur to produce a gas A. Here, a gas A is produced by the help of one volume of hydrogen and one volume of sulfur. If the vapor density of gas is 17, then the volume of each gas has been measured under the same temperature and pressure. That means indirectly it can say that it is the Avogadro's hypothesis you can apply. You can apply the Avogadro's hypothesis. Look at that. Now look at the solution. Here the reactant are hydrogen and sulfur. So here I can write hydrogen combine with the sulfur. Here I can say that hydrogen combine with the sulfur gives gas A. Okay. As per the data, here one volume of hydrogen and one volume of sulfur is given. Let one volume let one volume of each gas. Suppose One volume of each gas carry n molecules. Here the volume of hydrogen is your one volume. So by applying the Avogadro's hypothesis, here I can say that n molecules. Again I want to reply. This is the given data. This is the given data. Here let one volume of each gas carry n molecules. Then here I applied the Avogadro's hypothesis. By applying the Avogadro's hypothesis, I can write here n molecule, because both hydrogen and sulfur are one volume. So here I can write n molecule. Here equal volume of hydrogen and sulfur is given. So as per the Avogadro's hypothesis, I have written n molecule. I can also write m molecule, x molecule as your choice. Suppose I want to divide by n. That means n molecule divided by n. Here for sulfur, n molecule divided by n. That means here I can simplify. One molecule of hydrogen react with one molecule of sulfur to produce gas A. We know that one molecule of hydrogen, remember, one molecule of hydrogen means two hydrogen atom. But if you want to say about the sulfur, here one molecule of sulfur is taken, but you cannot confirm that how many atoms are present in one molecule of sulfur. You cannot give the guarantee that how many number of atom present in one molecule of sulfur. So here I can write another step. Two atoms of hydrogen combine with one molecule of sulfur to form the gas A. So here I can say that the hydrogen molecule contain two hydrogen atom. Therefore, here due to this, two atom of hydrogen combine with the one molecule of sulfur. Let suppose, so the formula, our target to find out the formula. Suppose the formula of A is your H2SX. Here X is the number of sulfur atom. Look at that. Here two hydrogen atom is present. So here I have written H2. Since I do not know the number of sulfur atom, so here I have taken X is the number of sulfur atom. Then I can write the formula of A is your H2SX. Now I apply the formula. Molecular mass of A is equal to 2 into vapor density. Here we can apply molecular formula. Molecular mass A of A is equal to 2 into vapor density. Here vapor density is given, that is your 17. Vapor density is given, that is your 17. So here I can put the value of vapor density, that is your 17, and I can find the molecular mass of A by using the atomic mass. Look at that. If you will think about the molecular mass of A, then you can write atomic mass of hydrogen plus atomic mass of sulfur. Here, two hydrogen atom is present, so here I can write 2 into atomic mass. Here x atom of sulfur is used, so x into atomic mass of sulfur. Finally, I can say that molecular mass of A is equal to 2 into atomic mass of hydrogen plus x into atomic mass of sulfur. Here x is the number of sulfur atom. So now I will put the atomic mass of hydrogen. Atomic mass of hydrogen is your 1. Atomic mass of hydrogen is your how much? 1. Atomic mass of sulfur is your 32. We do not know the number of sulfur atom, but we know the atomic mass of sulfur is your 32. Atomic mass of hydrogen is your 1. So here I can write, in the second step, I can write 2 into 1 plus x into 32 is equal to 2 into vapor density. Now I can simplify. 2 into 1 means here 2. X into 32 32 means 32x. That means here I can write 2 plus 32x is equal to 2 into vapor density. So here I can write 2 plus 32x is equal to 2 into 17. Next, here I can say that 2 plus 32x is equal to 34. So here I can write 32x is equal to 34 minus 2. That means here I can write x 32. 32x is equal to 32. Imply that here I can say that x is equal to 32 by 32, that is your 1. Here the x value is your 1. That means the number of sulfur atom is your 1. I have taken the molecular formula is your what? H2SX. Now put the value of x here. Here I can write H2S1. That means H2S. Here the molecular formula of A is your what? H2S. Our target, what is our target? What was our target? Find the molecular formula. Okay, I got it. The molecular formula of gas A is your H2S. This is the problem number 1. Here, here the question is slightly here the question have written in wrong manner. That means again I will correct the question like that. One volume of hydrogen combined with one volume of sulfur to produce a gas A. If the vapor density of a gas A is 17, the volume has been measured under the same temperature and pressure. What is its molecular formula? This is the answer. Next, move another question. Here, air contain, I have taken air, and the air contain 20% of oxygen by volume. That means, what is the meaning? What is the meaning of this sentence? If you want to find 100 ml of air, if you will take 100 ml of air, then 20 ml of oxygen is only found, and the rest is another gas, that is your nitrogen, carbon monoxide, as your choice. You can think here air contain 20% oxygen by volume means if you will take 100 ml of air, then 20 ml of oxygen is found. Calculate the theoretical volume of air that will be required for burning 200 meter cube of acetylene gas completely. All volume are measured under the same temperature and pressure. That means you can apply the Avogadro's hypothesis because all gases are present in the same temperature and pressure. As per the question, our target to find what amount of air is needed for burning 200 meter cube of acetylene gas. Look at that. If you will burn the acetylene gas, the formula of acetylene gas is your C2H2, ethyl. Acetylene, other name is your ethyl, C2H2. If you will burn the ethylene gas, monoxide and water is formed. If you want to balance, then here 2C2H2 plus 5O2 gives 4CO gives 2H2O2. Again I will repeat, 2C2H2 plus 5O2 gives 4 carbon monoxide and 2 water. So here I can write 2 volume, 5 volume, 4 volume, 2 volume. What are the coefficient are written in the reactant and product species? You can simply write here. Balance the equation and write the coefficient in terms of volume. Look at that. Here 2 is the coefficient, here 5, here 4, here 2. So I have written 2 volume, 5 volume, 4 volume, 2 volume. Look at that. I have taken how much volume of acetylene? 200 meter cube. That means equation, as per the balanced equation, here 2 volume of acetylene is found. That means 2 volume must be equal to 200 meter cube. Here I can say that as per the question, from the question, it can be found from the question. You can say that 2 volume is nearly equal to 200 meter cube. Since all the gases carry equal numbers of equal numbers of molecules, so here we can say that 2 volume is equal to nearly equal to 200 meter cube. For 1 volume, we can say that 200 by 2 meter cube. For 5 volume, 202 divided by 5, that is your meter cube, that is your 500 meter cube. That means, as per the equation, here I can say that 200 meter cube of acetylene react with a 500 meter cube of oxygen. Remember, this oxygen is pure. This is not air. This is oxygen. But you need the air. But your target to find, but your problem based on the air. But we know that the oxygen for 200 meter cube for burning of 200 meter cube of acetylene, we need 500 meter cube of pure oxygen. This is your pure oxygen. Look at that. So here I can write 500 meter cube of oxygen is required for the complete combustion of 200 meter cube of acetylene. Look at that. According to the question, 2 meter cube of oxygen is present in 100 meter cube of air. Already I discussed 100 ml of air carry to 20 ml of oxygen. This is 20%. Here I have taken meter cube. So here I can write 20 meter cube of oxygen is found in 100 meter cube of air, because 20% of oxygen is present in air. So our target to find out the 500 meter cube of oxygen. So here I can write 20 meter cube of oxygen is found, 100 meter cube of air. Our target, how much air contain 500 meter cube of oxygen. So here I can write 500 meter cube of oxygen will present in air. In the volume of air is your how much? 100 divided by 20 divide into 500. Look at that. For 20, 100. For 1, 100 by 20. For 500, here you can say that 100 by 20 into 500. After solving, you can find the answer 2500 meter cube of air. Exactly 500 meter cube of oxygen is needed for 200 meter cube, but here air is used. Air is contain 20% of oxygen only. So if you use pure oxygen, then 500 meter cube oxygen is sufficient to burn 200 meter cube of acetylene. But if you use air for burning of acetylene, then 2500 meter cube of air is used to burning 200 meter cube of acetylene. So the answer is 2500 meter cube of air. This is the second problem. This is all about the Avogadro's hypothesis and the application and some problem related. I have completed all the parts of the Avogadro's hypothesis. For this class, now this is sufficient. This is sufficient. So I will stop here. Thank you for watching the videos. You continue to watch the video. Uh, all the videos are available in the YouTube. It is highly necessary to inform you. If you want to note of each class, then go to the description and then you will find a link, and then you click the link, then you can able to find the note. You download the note and read well. Thank you very much for watching the video. Have a nice day.